Hi, everyone. My name is Marc. I'm an instructor at Dalhousie University in the Department of Chemistry. And for the last 5 or 6 years, I've been teaching the lecture and lab components for our Introductory Inorganic Chemistry, which is a second-year course that focuses on bonding models and main group chemistry. Just a bit of a review of how the course looked pre-COVID. It was a traditional layout with a lecture component and a lab component. 3 in-person lectures, Monday, Wednesday, and Friday, covering lecture content with the use of Housecroft and Sharp Inorganic Chemistry textbook, with the usual assessments of 2 midterms and a final exam. The laboratory component took place on Thursdays or Fridays in 3-hour sessions. Our last iteration pre-COVID had 4 experiments that were hands-on, 1 computer lab involving Gaussian simulations, and then a presentation. And typically, the students would be supervised in the labs by grad student TAs, and assessments would be largely carried out by them. And I have a dotted line between these 2 sections because for a variety of reasons, it's not always possible to completely integrate topics in the lab with the lecture. So there was a degree of integration, but not complete. So with the advent of the limitations of COVID, we converted labs to an online format. So we used the shortcut editing program for preparing videos of procedures. The pre-lab quizzes, procedures, and post-labs were rewritten. This involved a lot of reflection, and this gave us an opportunity to really look at the content of the labs and to see how they connected with the lecture component of the course. Basically, what ended up happening is the labs became assignments because we worked hard to make them integrated with the course material, and with no hands-on component, it was really hard to distinguish between labs and assignments. So we really ended up with a lecture and lab that was much more integrated, at least from my perspective. We'll see what the students thought about that when we get there. I wanted to just showcase one of our new labs. We had a chance to run this lab once before COVID, and then we modified the lab in order to run it under the COVID conditions. This particular lab is looking at the decomposition of alkaline earth carbonates. So effectively, we have magnesium or calcium carbonate. When you heat it up, you get the oxide plus CO2 gas. So we set up a process system where we had nitrogen gas flowing through a quartz tube. Inside the quartz tube, we have a quartz boat with a pre-weighed amount of a carbonate. And then as we heat it up in a clamshell furnace, we generate CO2 gas, which we could then measure using a gas cell. Students soon found out that for the case of magnesium carbonate, there was a very low decomposition temperature, and for calcium carbonate, a very high decomposition temperature. And we gave the students the ionic radii. So the students were given the challenge of figuring out why this would be the case by looking at the thermodynamics. And this allowed them to connect with some of what they learned in first year. So delta G for this process is really a reflection of temperature and the equilibrium constant. And for this reaction, the equilibrium constant is just the partial pressure of CO2 that's generated. The enthalpy term dominates the overall process, the Gibbs free energy change, and that the enthalpy change can be calculated using a Born-Haber cycle involving the lattice enthalpies for these compounds. And calculating the lattice enthalpies for these compounds was a big part of the course because one of the topics was the structure and thermodynamic behavior of ionic inorganic compounds. Lattice energies would depend on cation size, so this gave the students the opportunity to really understand or explain what the cation size had to do with the temperature. The second part of this paper involved a real measurement of the ionic radii for magnesium 2+ and calcium 2+. And we did this by running X-ray powder diffraction data for the oxides that were isolated in these reactions. Because the oxides are cubic, There's one lattice parameter. And so students were given indexed X-ray powder diffraction photos and a magic equation, which allowed them to solve for the lattice parameter. And then given the ionic radius for O2 minus, they could then calculate the ionic radii for magnesium 2 plus and calcium 2 plus. They then compared that with the literature values and got exactly the same numbers. So this was very satisfying for them to realize that it is possible to experimentally measure these otherwise nebulous concepts of ionic radii. So we were quite happy how this lab was very integrated with the course material, the lecture material. I want to very briefly just talk about what we did with the rest of the course. So because we were redoing the lectures for videos, it gave us the opportunity to really rebuild the course. So the first thing we did is with each lab or assignment, we developed learning objectives, which were always partially written out before, but we really had to write them out in this case. And then we wrote the assignment questions. And then from that, we reverse engineered the lecture content when we created the videos. So now we have these assignments that are really integrated with the lecture material. These would be released on a Monday. And during the week, we had office hours available to the students to talk with myself or our coordinator about the problems they might have been encountering. As well, we had tutorials on during the lab slots. So these were organized so that 4 to 6 students could participate in an online tutorial with the Teams platform and work through the assignments and hopefully gain some active knowledge of the material. There were participation points associated with this to motivate the students to work on it before they showed up. In order to run this, I had 2 graduate student TAs running tutorial sessions, as well as myself. The students would pass in the assignments on the Monday, and then we would repeat the cycle. So this was a lot of work, as you can imagine. So our department allowed me to hire a student coordinator, which was essential to making this all happen. So from the instructor perspective, this was an incredibly integrated active learning opportunity for the students. The student perspective is a different story altogether. And so there was a lot of learning in that for me. So I'd just like to talk a little bit about what we want to keep and what we probably will have to improve. So what we kept, or what will be kept, the improved alignment of lecture and lab content, I think was very important, and we'll definitely find ways to keep that. When we move to in-person labs, we're still going to keep the online procedures and videos because this is an excellent way to enhance the preparation of the students before they show up to the lab. The weekly assessed assignment tutorial cycles. As I mentioned before, from the instructor perspective, this looks really great, but the student responses were highly polarized. And I just want to talk about that a little bit. Some of the students loved this approach. They saw this as a opportunity to learn the material on a very deep level on a weekly basis. There was no memorizing or cramming for tests. And there was a lot of student feedback that it was great. There was a lot of students who hated it. They really hated it. They said there was too much work. It was very difficult to organize. And they were also intimidated by the tutorials, even though we worked very hard to keep things very friendly. So there's a lot for us to think about in this approach. Another thing just to be mentioned is that this was very labor intensive. The grading was very intensive with these weekly cycles. So we will have to come up with a different grading scheme or significantly scale back in what we're doing. I'd like to acknowledge 3 graduate students who really helped to build this course and implement the course: Kate Marshenko, Torin Hines, and Joe Bedard. And I'd also like to thank our department chair, Norm Shep, and our administrator, Danielle Potty. They really helped us out a lot. The The course, like many courses, were a moving target. Very hard to estimate beforehand what resources would be required to make it work. And they really helped us out. So thanks to them.